Hi, I'm Mr. Huber, and in this video we're going to talk about problem 3a and 3b. Look, in the last lesson we talked about parabolas, quadratic functions. Well, this is a quadratic function and this is its graph. This is the simplest quadratic function we know. Well, you plug in all the values from -3 to 3. Well, that's just some values. I could have taken other ones, or I could have taken many more, but I've plugged in these x values and I got these y values, and I draw the graph, okay, or I drew the graph. Now today we're going to look at a function like f of x is equal to x squared plus 3. Look, that's very similar to the one we had. But now we have to add 3. So what's going to happen? Well, look, if I plug in f of x, so I'm setting up my table because I want to see a pattern here. -3, -2, -1, 0, 1, 2, 3. Now let's plug in -3, for example. Well, -3, don't forget the brackets, plus 3. This is 9 plus 3, this is 12. So f of -2, here we go, -2 is -2 squared plus 3. Well, that's 4 plus 3, that's 7. Then f of -1 is -1 squared plus 3, so that's 4. f0, that's now 0 squared plus 3, so it's just 3. So let's write these in here. Okay, fill this in. Now f of 1, you see that's going to be the same thing again. You don't need the brackets here because there is no minus sign, so let's just get rid of it. So 1 squared is 1 plus 3 is 4, and you see when you plug in 2 and 3 will happen the same thing. F of 2 is 2 squared plus 3. Well, that's 4 plus 3, it's 7. And then f of 3 is 3 squared plus 3, which is 12. So I hope you can see it's very much the same thing as the one we saw last time, only that we add 3 to every y value. So what's going to happen? That's quite obvious. Everything is shifted upwards by 3 units. Here we go. Then at 2 it's at 7, at -2 it's at 7 as well, at 3 it's at 12, and at -3 it's at 12 as well. So let's draw a smooth parabola, smooth graph here. See? And you see, it's the exact same function or graph as here, only shifted up by 3 units, or translated upwards by 3 units. We say it's translated vertically by 3 units. So this made everything go up by 3 units, okay, compared to this one. Now when you look at B, well, there you have f of x is x squared minus 3. So what's going to happen here? -3, -2, -1, 0, 1, 2, 3. Well, that's quite obvious because f of -3, for example, -3 squared minus 3, so that's 9. 9 minus 3, that's 6. Look again, 9, but now -3, so that's 6. Now f of -2 is -2 squared minus 3, so that's 4 minus 3, that's going to be 1. Again, 4 minus 3, it's 1. So now we see what's going to happen. We can take this table here and just subtract 3 everywhere. So 1 minus 3 is going to be minus 2, minus 3, minus 2, 1, and 6. Let's check whether that's right. For example, for 2, f of 2 is 2 squared minus 3. Obviously, that's 1. Okay? Because it's the exact same function as the original parabola, but we subtract 3 for every y value. And now what's going to happen? Well, it starts down here. And see, 1 to the right, 1 up, 2 to the right, now 4 up, and 3 to the right, 9 up. So it's going to be 6. Here, 1 to the left, 1 up, 2 to the left, 4 up, because look, when you do 2 to the left, it's 4, but then minus 3. And as you start with your vertex at minus 3, it's 4 up. And 3 to the right, now it's 9 up. And you see, the graph is the same, but it has been translated downwards by 3 units. Okay? So we have 3 times the same function here. 3 times it's the same function. Once it has its vertex at 0 for x squared. Here it has its vertex at 3, 0, 3. And here it has its vertex at 0, minus 3. Well, when I said at 0, well, we mean at 0, 0, at the origin. I have to be clear. This has its vertex at the origin. So you see, apparently the minus 3 and the plus 3 does nothing than shift this upwards or downwards. Okay, I hope it wasn't too difficult. See you in the next one.